G'day guys, in this video I'm going to introduce you to the basics of polynomials. Polynomials appear in many areas of mathematics and science. For example, they are used to form polynomial equations that mathematically encode a wide array of problems, from elementary word problems to complicated scientific problems. In addition to this, polynomials, through their use in functional analysis, appear in settings ranging from basic chemistry and physics to economics and social science. They are also used in calculus and numerical analysis to approximate and model the relationship between both natural and theoretical phenomena. In other words, the idea of a polynomial is a very big concept in mathematics. So let's make sure you're paying attention. Now, before we can understand what polynomials are, we first need to learn about what mathematicians call terms. In algebra, terms are mathematical expressions that are made up of two different parts, a number part and a variable part. In a term, the number part and the variable part are multiplied together. But since multiplication is implied in algebra, the two parts of a term are usually written right next to each other with no multiplication symbol between them. The number part is pretty simple. It can be any real number, like 3, 12, or a fractional term such as 5/3. In mathematics, the number part which sits in front of each term is called the coefficient. The variable part of a term is a little bit more complicated. A variable is a symbol which is usually a letter that is used to represent one or more unknown numerical values. Mathematicians label terms which contain only a single variable as univariable, whereas terms which contain two or more variables are similarly labelled as multivariable. An important feature of terms which make up polynomials is the power that each of their variable components is raised to. To classify as a polynomial, each of the variables can only be raised to a non-negative integer power. As a side note, mathematicians call the set which contains only non-negative integers such as 0, 1, 2, 3, and so forth as the set of all natural numbers. If a variable is raised to a power which falls outside of the set of natural numbers, for example -3 or 1.5, the expression that this term is part of cannot be classified as a polynomial. Okay, so that's the basic idea of a term, but there's a little more to terms that we'll learn in a minute. First, let's see how this basic idea of a term helps us understand the basic idea of a polynomial. A polynomial is a combination of many terms that are all linked together using addition or subtraction. You could think about it like a chain of terms whose links are the mathematical operations of addition and subtraction. As we learned at the very beginning of this video, the coefficients and variables which make up each of the terms within a polynomial are linked together by multiplication. But it is important to remember that each term in a polynomial must be joined by either addition or subtraction. And it is worth reiterating that polynomials can be made from any number of terms joined together. But there are a few specific names that are used to describe polynomials with a certain number of terms. If there is only one term, which isn't really a chain, then we call it monomial, because the prefix mono means one. If there are just two terms, then we call it binomial, because the prefix bi means two. If there are three terms, we call it a trinomial, since the prefix tri means three. And beyond three terms, we usually just say polynomial, since poly means many. And in fact, it is common to simply use the term polynomial even when there are just two or three terms. Okay, so as a reminder, the basic idea of a polynomial is a series of terms that are joined together by addition or subtraction. Now, let's see a typical example of a polynomial that will help us learn a little more about terms. Here we have 7x squared plus x minus 9. How many terms does this polynomial have? Well, based on what we've learned so far, you're probably not quite sure. If the terms are the parts that are linked together by either addition or subtraction, then this expression should have three terms. However, it looks like there's something missing with the last two terms. The middle term seems to be missing its number part or coefficient, and the last term is missing its variable part. The middle term is easy to explain. There really is a number part there, it's just 1. Do you remember how 1 is always a factor of any number? And since multiplying by 1 has no effect on the variable or its coefficient, we don't need to show it. So, if you see a term in a polynomial that only has a variable part, you can now recognize that the number part or coefficient of that term is just 1. So what about this last term that's missing its variable part? Well, that's a little trickier. To understand this part of the polynomial's construction, recall the index law which states that any number or variable that's raised to the 0 power just equals 1. That means that we can think of this last term as having variable x that is being raised to the 0th power. Since this would always just equal 1, it's not really a variable in the true sense of the word, and it has no effect on the value of the term. In addition, when considering the variable on the middle term, if we recall the index law which states that any number raised to the first power is just itself, we can see that the middle term can be also expressed as 1x raised to the first power. So, are we beginning to see a pattern? Each term has a number part or coefficient, and each term has a variable part that is raised to a power, whether it be 0, 1, or 2. But since x to the 0 is just 1, and x to the 1 is just x, and anything multiplied by 1 is just itself, the polynomial gets simplified so it no longer looks exactly like the pattern it comes from. Finally, the last term, and the one that doesn't have a truly variable part, is labelled as a constant term because its value always stays the same. So, now that we've got our head around what a polynomial is, let's talk about an important property of terms and polynomials called their degree. Now this might sound like the units we use to measure temperature or angles, but the degree we're talking about here is different. In this circumstance, the degree of a term is determined by the power that its variable part is raised to. For example, in this term, since the power of the variable is 3, we say that the degree of the term is 3, or that it's a third degree term. And in this term, the power of the variable is 5, so we either say that the degree of the term is 5, or that it's a 5th degree term. Likewise, this would be a 2nd degree term, this would be a 1st degree term, and I guess that it is technically correct to call a term with no variable part a 0 degree term, but it's usually just referred to as a constant term. Things are a little more complicated when you have terms with more than one variable. If you are presented with a term with more than one variable, its degree is found by taking the sum of the powers of each of its variables. Since the powers in this term are 3 and 2, it's a 5th degree term because 3 plus 2 is 5. Likewise, in this term, the powers are 3, 2 and 6. So we would call it an 11th degree term because 3 plus 2 plus 6 is 11. Okay, but why should we care about the degree of terms? Well, it's because polynomials are often referred to by the degree of their highest term. Take this polynomial for example. Because it contains a 4th degree term, but no terms of a higher degree, then it's labelled as a 4th degree polynomial. Another reason that we care about the degree of the terms is that it helps us decide on the correct arrangement of a given polynomial. When arranging terms in a given polynomial, mathematical convention states that we should arrange its terms in order from the highest degree to the lowest. For example, this polynomial, which has 5 terms, should be arranged so that the highest degree term is on the left and the lowest degree term is on the right. But of course, not every polynomial has a term of every degree. This, for example, is a 4th degree polynomial but only has 3 terms. However, we should still put them in order from highest to lowest, even though it has some terms that are missing. So the 5x to the 4th should come first, and then the minus 3x, and finally the plus 9. By the way, it's totally fine for a polynomial to have missing terms like that, and it's sometimes helpful to think of those missing terms as just having coefficients that are all zeros. If the coefficient of a term is 0, then the whole term will have a value of 0. As a result, mathematicians do not include these terms because their presence has no effect on the overall polynomial. Speaking of coefficients, What if we need to rearrange this polynomial so that its terms are in order from highest degree to lowest degree? The highest degree term is 4x squared. But before we just move it to the front of the polynomial, it's important to notice that it's got a minus sign in front of it. Normally, when we see a minus sign, we think of subtraction. But when it comes to polynomials, it's best to think of a minus sign as a negative sign. That means the term right after it has a negative value, or a negative coefficient. In fact, instead of thinking of a polynomial as having terms that are either added or subtracted, it's best to think of all the terms as being added together, but that each term has either a positive or a negative coefficient, which is determined by the operator right in front of that term. For example, if you have this fourth degree polynomial, you should treat it as if all of the terms are being added together and use the sign that's directly in front of each coefficient to tell you if the term has either a positive or a negative value. This first term has a coefficient of -5, so it is a negative term. The next term has a coefficient of +7, so the term has a positive value. The next term has a coefficient of -8, so the term has a negative value. The next term has a coefficient of -3, so the term has indeed got a negative value. And finally, the constant term is just +9. And recognizing positive and negative coefficients helps us a lot when rearranging polynomials that have a mixture of positive and negative terms, like in our example here. If you think of the negative sign in front of the 4x squared term as part of its coefficient, then you'll soon realize that when we move it to the front of the polynomial, the negative sign has to come with it. It has to come because it's really a negative term. And if we don't bring the negative sign along with it, we'll be changing it to a positive term, which would actually change the overall value of the polynomial. In addition to helping us rearrange polynomials, treating them as a combination of positive and negative terms will also be very helpful when we need to simplify them, which is definitely a topic for another video. All right. We've learned a lot about polynomials in this video, and if you're feeling a little overwhelmed, don't worry. It may just take some time for it all to sink in. And last but not least, if this video helped, please consider liking it and subscribing to my channel. It really helps get my videos noticed by the YouTube algorithm and allow my channel to grow. Also, if you have any ideas for mathematical videos in the future, please don't hesitate to leave them in the comments section below. And in wrapping this video up, I'd just like to remind everyone that maths problems are called problems for a reason. They're supposed to take you time to solve and give you a little bit of a headache while solving them. But that's what really makes the actual finding of the solution a worthwhile process. So what I suggest you do, guys, is keep banging your head against the wall. Eventually the wall will fall down. But as long as you continue to enjoy the problem-solving process, give it enough time, in my experience, everyone is able to achieve some form of success.